Level 0. Let's start small, and I mean really small. The needle tornado is the skinniest of them all. Picture a thread dangling from the sky, barely thicker than a streetlight pole. It doesn't twist dramatically or roar with drama like the monsters you see in movies. It just drops straight down like a pencil, stabbed through the clouds. Quick, quiet, and oddly elegant. Needle tornadoes are usually brief, often lasting only a couple of minutes. They're the sneak attacks of the tornado world. Blink and you might miss one forming in the distance. But just because they're small doesn't mean they're soft. Even the narrowest funnel can contain winds strong enough to peel shingles, flip light vehicles, and toss debris like confetti. Most needle tornadoes appear early in the storm's life cycle. Think of it like the storm testing its grip. The rotation starts to tighten, the lower pressure begins to stretch downward, and suddenly this narrow stalk of swirling air connects the sky to the ground. It's nature's version of a sketch before the full painting. They often form in high plains regions, where dry air and flat terrain make it easier to spot even the smallest details in the sky. Chasers call them photogenic, which is a polite way of saying, yeah, that one probably won't kill me. But every storm has potential, and the needle, while tiny, can still punch above its weight. One fascinating thing about these tornadoes is how clean they look. With little debris and no wide base, they can appear almost ghost-like. Sometimes you'll only see them because they're kicking up a trail of dust behind them. They look harmless, almost playful. But storms don't stay playful for long. As the wind structure strengthens and the pressure tightens, the tornado begins to stretch. It gets longer. It begins to bend. The once straight stalk starts to twist, curling and weaving like a thread caught in a storm. It's no longer just a line. It's moving, slithering, winding across the sky in search of solid ground. And that's when it becomes something else entirely. It becomes the rope. And now the storm has found its rhythm. Level 1. When a tornado stretches out and starts to twist like it's dancing, that's when you know the rope has arrived. The rope tornado is long, thin, and flexible. It slithers across the sky like a ribbon caught in a storm, often curving and bending as it drifts across the landscape. At a glance, it almost looks elegant. It moves with a strange kind of grace, swaying side to side as if it's performing for an audience. But don't get too comfortable. This isn't a show. It's a warning. Most rope tornadoes appear during the final stage of a tornado's life cycle. The storm begins to lose energy, and the once massive funnel starts to narrow and twist. What remains is a thin, winding strand of wind that slowly unravels back into the sky. But here's the catch. Rope doesn't always mean weak. In fact, some of the strongest tornadoes ever recorded have ended in the rope stage. And while their winds may be concentrated into a much smaller area, they're still powerful enough to rip the roof off a house, fling debris across entire fields, and leave behind a trail of shredded metal and snapped trees. They're also unpredictable. Rope tornadoes often sway side to side or suddenly change direction. The structure is looser, the motion less stable, and that makes them harder to track. For storm chasers, this stage is risky. The tornado is still dangerous, but harder to see and more likely to surprise you. And then there are the rope tornadoes that start this way. Some tornadoes form as ropes, then grow into something much bigger. The 1992 Heston, Kansas tornado began as a narrow rope and eventually evolved into a violent, multi-vortex wedge that left entire neighborhoods in ruins. So when you see a rope tornado starting to widen, that's not good news. That's your cue to move. Visually, rope tornadoes are fascinating. They can loop, curve, and even appear to snake along the ground. Sometimes they break apart into smaller spinning tendrils. Other times, they vanish in seconds without a trace. But when conditions are right, they shift, they stabilize, and they grow. The twisting thread starts to thicken, the curve becomes more controlled, the wind tightens its grip, and suddenly the funnel no longer looks like a rope at all. It starts to look like something alive, reaching down with a long, powerful arm. It starts to look like an elephant trunk, and that's when the storm begins to focus. Level 2. Some tornadoes don't just drop, they reach. The elephant trunk tornado is one of the most recognizable and oddly graceful forms a tornado can take. The name fits perfectly. It curves downward from the clouds like the trunk of a giant animal, thick at the top, tapering toward the ground, and often swaying as if it's searching for something. It's slower than the rope, steadier and heavier. And while it may look peaceful compared to the chaos you expect from tornadoes, don't let the shape fool you. This is a transitional form. When a tornado begins to strengthen, it often passes through the elephant trunk stage. The rotation has tightened, the energy has stabilized, and the storm is locking into its structure. The funnel becomes more defined. The winds pick up speed. The danger becomes more real. What makes this shape so deceptive is its appearance. It doesn't have the violent spin of a multi-vortex tornado or the massive size of a wedge. It's lean, it's curved, and it almost looks slow. But inside that slender column is a concentrated engine of destruction. The winds are fast, the rotation is intense, and when it touches down, it can tear through buildings just as easily as its larger counterparts. In 2007, near Tulia, Texas, chasers documented a textbook elephant trunk tornado that touched down in open farmland. For a few minutes, it twisted like a living thing, carving narrow scars across the plains. Then it thickened, it straightened, and it transformed into a powerful stovepipe tornado that ripped barns from their foundations. This is why elephant trunk tornadoes matter. They are the calm before the escalation, They're beautiful in a way that's almost unsettling. They lull you into watching, mesmerized by the curve, unaware that the system is still evolving. From a scientific angle, the shape forms as the storm's updraft pulls more rotating air into the funnel. The top widens, the pressure drops, and the tornado begins to stretch downward. The result is that distinct trunk-like shape that gives the impression of control. But storms don't stay in control forever. As the tornado stabilizes and the winds increase, the funnel starts to change again. The curve fades. The sides sharpen. The trunk loses its lean and becomes something more direct. It becomes wider at the top, narrower at the bottom, and dead set on the ground like a spear. That's the cone. And the tornado is just getting started. Level 3. This is the tornado you've seen in photos, textbooks, and disaster documentaries. The cone, broad at the top, narrowing to a sharp point at the bottom. It's the classic tornado silhouette, and for good reason. This is the shape of a tornado in full control. Stable, balanced, and dangerous. The cone tornado usually forms when the storm reaches maturity. The updraft is strong, the rotation is tight, and the environment is feeding energy into the system like fuel into a fire. The shape itself comes from this balance. As warm air rises into the storm and cooler air wraps around it, the funnel grows wider at the cloud base while still maintaining a narrow connection to the ground. It's a sign that the tornado isn't struggling anymore. It knows exactly what it's doing, and what it's doing is damage. Cone tornadoes are often long-lived. They can travel for miles, carving paths through farmland, towns, and cities with terrifying efficiency. They have enough structure to remain steady, enough strength to level buildings, and enough visibility to give you just enough time to realize you're in trouble. In 2013, a cone tornado developed near Roselle, Kansas. Chasers watched as the slender funnel stretched and grew, eventually forming a perfect triangle that touched down and tore through open land. It was mesmerizing. The tornado looked almost too perfect, too clean. But in reality, it was a high-end EF4 with winds strong enough to tear pavement from roads. Cone-shaped tornadoes are also a turning point. Once they reach this form, they don't stay still. They're either about to shrink, collapse, or grow into something even worse. When the energy feeding into the tornado increases, the base starts to widen. The sides straighten. That smooth tapering disappears. It doesn't look like a cone anymore. It looks like a column, a vertical tower of rotating air, uniform from top to bottom. That's the next form in this storm's evolution, the stovepipe. And that's when the tornado stops looking like a funnel and starts looking like a structure. Something built, something permanent. Because when the cone grows into a stovepipe, it means the tornado isn't just balanced, it's focused, it's locked in, and it's ready to cause real damage. Level 4. When a tornado becomes a stovepipe, everything changes. Gone is the tapered shape of a cone. Gone is the graceful curve of an elephant trunk. What's left is a thick, vertical column of rotating air that stretches from the clouds straight down to the ground. Uniform in width, solid in structure. It does not look like it is forming. It looks like it has already arrived. The stovepipe tornado is a signal of strength. It forms when the rotation inside the storm becomes fully organized. The inflow is locked in. The updraft is powerful and consistent. And the tornado has reached a stage where it can maintain both form and force for an extended period. This is not a brief spectacle. This is a sustained threat. Visually, it resembles a smokestack or silo, towering, symmetrical, heavy. And that symmetry matters. It means the storm's energy is focused and stable. Wind speeds are often extreme, with the potential to reach well into the EF3 to EF4 range. This is the kind of tornado that does not just touch down. It cuts through whatever lies in its path. One of the most infamous examples of a stovepipe tornado happened in Elie, Manitoba in 2007. At first, it appeared to be a slender funnel. Then it thickened into a perfect stovepipe, steady and ominous. Within minutes, it tore a well-anchored home from its foundation and hurled it into the air. It was Canada's first officially rated EF5 tornado, and it looked like a chimney from hell. The deceptive thing about the stovepipe is how simple it looks. There is no wild curve or chaotic motion. It appears calm, almost rigid. But that simplicity hides the violence inside. These tornadoes rotate with brutal speed and carry immense pressure differences. When they hit structures, the rapid drop in pressure can make buildings explode outward from the inside. And sometimes, the stovepipe does not stay contained. It starts to swell. The base widens, the top holds steady, but the middle begins to bow outward. The tornado begins to round out. It is no longer a column. It starts to breathe like a living thing. That is when the stovepipe transforms into something heavier, thicker, more monstrous. It becomes the barrel. And in that moment, it stops looking like weather and starts looking like a moving fortress, one that does not wobble, one that does not hesitate, one that consumes. Level 5. This is where a tornado stops looking like a funnel and starts looking like a machine. The barrel tornado is thick, heavy, and slow turning. The sides are rounded, the top and bottom nearly equal in width, and the whole thing seems to move with purpose. There's nothing fragile or uncertain about this stage. It's massive, it's grounded, and it means business. This shape often develops when a tornado reaches its peak size and intensity. All the elements inside the parent storm are perfectly aligned. The updraft is locked in, the inflow is pouring in from every direction, and the low pressure inside the vortex is pulling everything into its core. The result is a tornado that looks less like a weather phenomenon and more like a force of nature. Barrel tornadoes have been responsible for some of the most catastrophic events in storm history. In 2011, the Joplin, Missouri tornado took on a barrel-like shape as it carved a path through the city, becoming one of the deadliest tornadoes in U.S. history. The width of the funnel meant more homes, more schools, and more lives were in its direct line. What makes the barrel shape so dangerous is that it often gives the illusion of slow motion. The tornado seems to lumber across the landscape, but inside the winds can exceed 200 miles per hour. It doesn't need to move quickly to destroy everything it touches. These tornadoes are built to last. They don't flicker or twist unpredictably. They simply rotate and consume. And when the surrounding air is unstable enough, a barrel can evolve into something even stranger. Sometimes the pressure dynamics inside the tornado begin to stretch and bend. Instead of staying rounded, the tornado pulls in at the middle. It narrows and widens at once, forming a shape that almost seems impossible. The top is wide, the bottom is wide, but the center is pinched, as if the entire tornado has been grabbed at the waist. You're no longer looking at a cylinder. You're looking at something rare. Something unstable, something that doesn't fit the usual pattern. The tornado has twisted into an hourglass, and what happens next is anything but predictable. Level 6. This is where tornadoes stop playing by the rules. An hourglass tornado looks like it's been squeezed in the middle, as if some invisible hand pinched it between the sky and the earth. The top is wide, the base is wide, but the center dips inward into a narrow waist. It's a shape that doesn't seem to make sense at first glance. And maybe that's the point. Meteorologically, an hourglass tornado is a sign of imbalance. Something inside the storm is shifting. The vertical winds are clashing with horizontal forces. Pressure drops are tightening the funnel at different layers, creating a tension in the tornado's core. You're watching a structure that's being pulled from both ends, held together only by the raw force of rotation. These tornadoes are rare. You won't see them often, and when you do, they don't stay this way for long. The hourglass form is usually temporary, caught between stages of development or collapse. Sometimes it's a sign that the tornado is weakening. Other times it means something far worse is coming. In 2016, storm chasers in Colorado filmed an hourglass-shaped tornado over flat farmland. For a few moments, the funnel hung in the sky like an illusion, barely touching the ground. Then, with no warning, the bottom widened, the middle snapped outward, and the entire storm expanded into a wedge. The hourglass is deceptive. Its narrow middle makes it look fragile, but it is anything but fragile. Inside that waistline, the wind speeds can accelerate as air is forced through a smaller space. The vortex tightens, speeds up, and sometimes becomes even more violent. It's a moment of decision for the tornado. Will it stretch and snap? Will it stabilize and strengthen? Or will it collapse entirely? Because if it does hold together, and if it keeps growing wider, it no longer looks like a funnel at all. The shape flattens, the sides disappear, the top and bottom merge into one solid block of motion. It stops looking like a tornado and starts looking like the end of the world. The storm has dropped a wedge, and when that happens, almost nothing survives in its path. Level 7. This is where the tornado stops looking like a funnel and starts looking like a wall. A wedge tornado is wide, flat-bottomed, and so massive that it sometimes doesn't even look like a tornado at all. It blends with the sky and the ground, forming a solid, churning block that can stretch for over a mile in width. From a distance, it can be hard to even tell what you're looking at. There's no visible curve, no obvious rotation, just a black curtain slowly swallowing everything in front of it. Wedge tornadoes often form in high instability environments, where the storm's rotation is strong, sustained, and fed by massive inflow from all sides. And when you see one, you know things have reached a critical point. The wedge tornado is typically associated with the strongest and most destructive storms on record. EF4, EF5. Entire neighborhoods erased in minutes. In 2013, the El Reno, Oklahoma tornado reached a width of 2.6 miles, making it the widest tornado ever recorded. It started as a narrow funnel and rapidly expanded into a wedge that caught even experienced storm chasers off guard. What makes wedge tornadoes especially terrifying is how quickly they can form and how hard they are to see. Many are rain-wrapped, meaning they are buried inside sheets of falling rain. By the time you realize it is there, it might already be too late to react. These tornadoes are capable of throwing vehicles, leveling concrete buildings, and turning massive objects into flying shrapnel. They often have multiple vortices hidden inside, spinning like drill bits within the larger funnel, increasing damage in unpredictable bursts. The wedge is not just big, it is organized, deadly, and often relentless. It does not wobble, it does not drift, it moves like a machine programmed to flatten anything in its path. And when the skies finally clear and the storm lifts, what remains is often silent. silence. The kind that settles over fields, streets, and lives that were never supposed to be part of its path. There is no next level. This is where the shape ends.